So are you done with all the questions related to LinkedList? Sandeep, Aryan, Ritan, and others.
Like only did 5 till now.
Only did?
5.
Okay, from LinkedList or 2.0?
Yeah, from LinkedList.
Okay. Okay, let's start. So today we will cover the binary search. Do any one of you what is binary search? No. Okay. Okay. So do you guys remember the example which I gave you last time regarding searching in the dictionary?
Yes.
So what we were doing to find out the word in the dictionary, if you all remember.
Uh, we were reducing our search space by directly jumping to the character, given character.
So were we not doing something going at the middle of the book again and again, like dividing the search space by half again and again?
Yes. Your voice is breaking.
Sir, your voice is breaking.
Similar to that. Is it fine now? Is it fine now?
Yep.
Okay. Um, I'm sharing my screen. Now to share the window. Is my screen visible?
Yes.
Okay. Okay. So let's start with a basic question. Let's say we are given an array which is 1, 2, 3, 4, 5, 6, and 7. Now, if you want to find out uh, whether a number 4 present or not, how you will find it out? You need to find whether 4 is present in this given array or not. This is what you need to find out.
सर एरे को ट्रेवर्स कर लेंगे वहाँ क्लिक अप पेमेंट टेबल पर फाइंड हो गया आपको तो रिटर्न कर देंगे
So you are saying that you are going to traverse the array. That means first you will check, hey, whether the 1 is equivalent to 4 or not, then 2, then 3, and then 4, you will get it.
यस
Okay. What if I say that array is already sorted? Can we find it out in a much faster way? Sorted array.
Yes, we can use binary search.
We can use binary search. Okay. And what is that? Like how, like, I mean, let's not use the term here. Like how, what will be the steps to find out that?
Uh, we'll try to divide the search space on each iteration. Like first, we'll just start with the mid, and we'll check if my current value is greater than or less than the mid. If it is less than, then I know that my answer will lie in the first part of the array only. So,
Okay. So we don't need to look for the second half. We will only go to the first half.
right.
Okay. Okay. Let's see. There are two kind of search which you can use. One is the linear, the one which we have already talked about, linear. How many steps it will require? This check, this check, this check, this check. 4 checks total. 4 comparisons, I can say. Okay. Now let's see how we are going to solve it by using binary search. Okay. In binary search, first thing is the array on which we are going to apply the binary search. It should already be sorted. When we say sorted, it does not always mean that they always need to be sorted in ascending order. It can be descending order, and it can be strings also. It can be any kind of data structure which is arranged in some pattern. There we can apply binary search server. For example, here the array is already sorted. So in binary search, what we do is we create 2 pointers or 2 variables. One is low and other one is high. These are the indexes. So the first value is at 0 index. What is the value of last index? Basically, what is the height of the array? Sorry, yeah. The size of the array. 1, 2, 3, 4, 5, 6, 7. And so it will be 7 minus 1, which is 6. These represent the index of first value and last value of the array. We are saying this low and high signifies that, hey, we are trying to search something from 0 index to 6th index in the given array. This is what these variables signifies. Okay. Okay. Now, the next step is to find the middle. That, hey, let's see what is at the middle index between these low and high. So what will be the mid? How you will calculate the mid?
The low plus high divided by 2.
Low plus high divided by 2. Okay. I'm just writing it in the short form for now. So the answer would be 3. What is at third index of the array?
4.
4. So if I write it this way, array 3 is equivalent to what? 4. Now, what is the target we are looking for? Let's say, the number which we were looking for was 4. Now we can say we already find out the 4. Yes or no?
Yes.
Yes.
And how many comparisons we did for this? Only one.
Only one.
Yes. And for linear, how many comparisons we were doing?
4 comparison.
4 comparisons. So which is faster?
The binary.
Binary. Let's change the target for one more example. Okay. Let's say we are kind of trying to find 6 here. Okay. Now we got this value that, hey, the mid value is 4. Now, but we need to find out 6. The mid is pointing to 4, but we need to find out 6. So what should be our next step here? We know that all the numbers which are higher than 4 are in the right. When I say right, sorry, just 1 second. Let me do this and one this and this. Yeah. So our low is here, L. Our high is here, H. And our mid is here. Okay. Now our mid is at 4. Now we know we need to find out 6. And 6 is greater than 4. So now where we should start searching for the value? Should we search the value from L to M or M to H?
The M to H.
M to H, no? Okay. So what will be our new L and new H? Now we will have new low index and new high index. Okay.
The low index 3 and high 7. 6.
What is low index?
It's a 3.
3.
Index
Okay.
3. Yes, sir.
Okay. And what is high?
The 6. Index 6.
Okay. So the better way would be to say this, that, hey, high will not change. High is going to remain same and low will be mid plus 1. Why we need 3? Sorry, why we need to use 3 here? We have already checked the 3, na? So we can say,
yes,
hey, 5 to, we can say M plus 1 to H. So M plus 1 to H means 4 to 6. Correct?
Yes, sir.
Now let's do it again. Now what will be our new mid? Now this loop will keep running on and on until this low become equivalent to high or we find out the answer. What will be our new mid? You know the low, you know the high, you know the mid formula. What is the value of mid now? The new mid.
5.
5. Okay. And what is the value at 5?
6.
Okay, it is 6. So have we found out the answer? Yes. Within 2 comparison, we were able to find out our answer. But if we use binary like linear search, you would have used 6 comparison to find out the answer. Because first you will check 1, then 2, then 3, then 4, then 5, then 6. But now you are able to do it within what? Only 2 comparisons. Okay. Now let's say instead of looking for 6, now we are looking for 7. Just to cover up the entire question and see how far it can go. Now what should be our next step? If the target we are looking for is 7. Now you guys need to understand. Target is 7 now. What should be our next step now?
Calculate mid.
Don't you think we need to change low and high again? What will be our low and what will be our high?
The low is 6 and high are
Sorry, low is
6. And 6 is the 7.
sorry. Is it 6, 7? What can you just say?
The 6 is the
6. But 6 we have. Okay, correct. And what is high?
same value is that
High will be also 6. And what will be our mid?
6.
6. What is the value at 6?
7.
So that means we now find the answer.
Yes.
Is this clear? This is what we call the binary search. This can be only applied when the data is somehow arranged or sorted, we can say. Because here the array was already sorted. So we applied it. Is it clear to everyone?
Yes.
Yes, sir.
Okay. Now can you guys tell me how we can write the code for this?
Yep.
How?
We'll use a while loop in which our termination condition would be when low is less than, like, we'll continue to run the loop until low is less than high, and every time we'll calculate mid. We'll compare whether it's less or greater. If it's less, we'll move to first portion, otherwise later portion, and then we'll continue to run it.
Okay. Let's try to write it then. So we need to now write the code. Yeah. Okay. So what we need to find out is find target value. Let's say we are given an array and we are given a target. Now what should I do?
Initialize low and high.
Okay. With what?
0 and n minus 1, or array dot length minus 1.
Okay. Then
We'll start while loop.
what will be the condition in the while loop?
Low less than high.
Are you sure? In the last example, we saw that low was equivalent to high, and we saw.
Low
I
less than
think the
high.
low less than equal to high.
Okay. Correct. Then
Calculate mid.
calculate mid. Okay. Then
If array of mid is less than target, then
if array of mid is less than target,
then low would be mid plus 1.
then low would be mid plus 1. Okay, then
Uh, yeah, that's it. Like then else part.
okay. Then in the else part. I mean, okay. In the else what should I write?
High equals to mid minus 1.
High. Okay. 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 Is it complete, or do you guys think we need to change anything here in the code? Because I think so. Remember the steps which we have done on the
I think
whiteboard.
we need to return targeted for
You can just return whether the target is existing in the array or not. Just return true or false. But where I should write that true or false? So, like, where should I return?
Okay,
What
else,
is
yeah, else if and
so if I change the code, I would write it this way. Okay, return to else if array mid yes. What should I write here? Target. Okay, since the given target is low, and we should say then mid plus 1. Else, I would say I equivalent to mid minus 1, and if we are not able to find anything, that means return false. Are you guys able to understand this code or not? Yes, I will provide that also. Just see if you are able to open the code bank link which I have shared.
yes.
Yes, and check if any of the line is not able to, you are not able to understand any of the line. Sahil, yeah, we will come to the Java code also. Don't worry about that also. In the same in the same code bank, I have pasted the Java code link. Check it out. Oh, sorry, I think maybe yes. So here is the Java code for those who use Java. C++. I have added it in the same editor, the link which I have already shared with you. So this is the Java code, and the above one is the C++ code. Try to go through this and see if any of the part is not clear. Feel free to ask any question.
What if there are like elements are repeated, then it will return the index.
Yeah, we will talk about that. We will talk about the variations. Don't worry about that. This is just a very basic version. If you remember the way we did with the two pointer, adding the complexity layer one by one, we are going to do the same thing in this version. But let's first make sure that the basic concept is clear to everyone and everyone is able to code it also.
It's the
If you, yeah, sorry, can you, someone was saying something. I missed it a little. Yeah, Bapen, are you trying to say something?
I take bigger. I can.
I'm not able to clearly hear you. Maybe anyone is able to hear him, like what he is saying. Or maybe you can write in the chat because your voice is not clear to me. Clear. Okay. Okay. Got it. Got it. Got it. Okay. Mic. Yeah. Let me check. Sadia, your mic is on according to me. Can you please check? Maybe initially it was not, but I think now it's clear. Okay. Sahil, is Java code clear to you? Guys, please answer. We need to move on. Yes, no. Yes, sir. Okay. Okay. And Sadia, is your mic working fine? Just can you just check that once? Okay. 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 So this is clear to everyone. Let's move on to the next thing then. I will just wait for 10 seconds more if any one of you have any question. Otherwise, we will move to the next. Okay. Seems no. Let's move. So, what was your okay? Let me erase it and then, or instead of erasing it, let's move on to the next one. Yes. So now consider whether the uh, array is this 1, 2, 3, 4, 4, 4, 5, 5, 6, and 7. Now we need to find out the first index of target. Last time, what we were saying, just check whether the target means the value whatever integer is given to us is exist. Does that exist in the given array or not? Now we need to return its index. But what does this first index mean? For example, let's say target is equivalent to 4. Okay. Now you see there are 3 4s. So which index you will return here? You can return first index also. I mean, you can return 0, 1. Okay. Let me specify the indexes also. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. You can say, hey, 3 can be the answer, 4 can be the answer, 5 can be the answer because all of those indexes contain 4. But we need the first index of the target. That means answer should be 3. Simple thing is that. Now, how we should solve this question? Array is already sorted by the way. This is index. This is array and a sorted array actually. Now you guys tell me how we are going to solve this question.
We will use the previous approach only, and as soon as I found any one occurrence,
But we need to return the first index. Huh?
yeah, so as soon as I found any one occurrence, I'll go to the left side because I know first occurrence will always occur on the left side. So yeah, maybe that number of iteration would be more.
Let's say you have gone to the left side then.
As soon as I don't found any like not similar, like so let's say uh after binary search I ended up at index 4. I'll search if index 3 and 4 is same, then I'll move my left pointer again, then check 2 or 3 is same, and now it's not same, so I'll return 3.
Okay. So if we specify the step, first would be, let's say if you found target, if target found,
Then
because
just
that's
then
then
just
what?
uh traverse in the left side as much as you can up till you are getting the same value. As soon
Okay,
as you get the
travel
first left side.
left. Okay. Is this clear to everyone? Because if it is, then we will move on. So if it is not clear, just say that, hey, can you just explain it?
Sure, please explain this.
Okay. Okay. So what he was trying to say, let's say when you found out the mid, your mid, let's say, came to 4. Okay. At mid 4 is what? This one. But is this the answer? No. Because we need to return the first index of the target. First index of the target means कि जो टारगेट है वो एरे में सबसे पहली बार कब आया, सबसे पहली बार कब देखा है, और वो कब है, वो इट्स ऑन द थर्ड इंडेक्स. So what he is saying that, hey, we will start traversing the left. We will check, hey, check mid -1. Sorry. Check mid -1. What is mid -1? What is mid -1?
3.
3. Okay. Does third index also contains 4? Yes. Okay.
Yes.
Again, 3 -1. What is 3 -1? 2. Does 2 contain the same index? Sorry, same value? No. So we got the answer, which is 3. We will write the code also. I know maybe you are like getting confused with that. Hey, how I will be writing the code, that I can understand. But is the concept clear to everyone?
Got it,
By
sir.
the way, okay, yeah. By the way, we have done this thing in 2-pointer also. So if you remember, we were having a question where, hey, if the array is sorted and the numbers are repeated, what we were doing there, we were using a while loop to skip the numbers and reaching to the answer. I mean, we will code it. First, want to make sure that I approach clear to everyone. If yes, let's move to changing the code. Let's incorporate these changes. So now tell me what changes we should make here to make it work. So if I write it again, let's go to the bottom. Okay, yeah. Now we are finding first index of target. Now tell me what changes we should make here in the code.
Like instead of returning true, we can again have another while loop, which will run until array of low is not equals. Yeah, it's not
Are you sure array of low?
equals to of array of mid.
Okay, let's okay, you complete, then we see what will go inside.
Yeah, so now we know that my mid portion is the target element. I'll just move the left to left minus minus.
What should be the line? Code line.
Yeah, code line is left minus minus only. Decrement left pointer. Left equals to left minus 1 or
You mean low negative negative? Okay, then
uh yeah, it will continue and like yeah, I think that's enough. Like as soon as the loop will over, I'll just return the index like low.
okay. And let me tell you what I was thinking. What do you think about this?
Yeah, yeah, it's kind of same thing only, right? Like we can choose either mid or low. It doesn't matter. And we like the above code is we
No,
have to.
it will matter. It will matter. Let me tell you how. Let's say your low is here and your mid is here. Your while loop will not run.
Low
Again.
would be correct. Okay, got it. Right.
Okay. Do you still see any problem in line number 82? I mean, although conceptually wise it is correct, we are checking that hey, mid should be greater than 0. I hope you guys remember we have already done the same thing in 2 pointers, that hey, why we are checking whether mid needs to be greater than 0 or not. Then we are checking whether the current mid is the current mid value is equivalent to the previous mid value or not. If it is, then let's move on, something like that. I think we will not get this section. Is line number 82, 83, 84 clear to everyone? If no, just say it loud.
Sir, please again repeat line number 8.
Okay. So whenever we found the target, what we were saying that hey, we will keep checking the previous value. If we come to the whiteboard again, we found this 4 initially. Then we check if previous is the also 4. If it is yes, then move the value to there, because this can be one of the index. If previous value is again 4, do the same thing. For example, let's say 4, 4, and 4 is written. Your mid was here. You check whether this mid and m minus 1 is it equal. That means this can be our first index. This can be. Then you again check, hey, this is new m and this is m minus 1. Are they also same? Then yes. Hey, yes. Then again we will move to this. We will keep moving on to the left until we saw that hey, the left element is not equivalent to the current element, which is here. In this case, this will happen. And at that point of time, mid is pointing here. So we will return 3. If you come to code, if you maybe this is becoming an issue for you. For now, you can forget this line, just this part, the selected. Are you able to understand this line, what we are doing here?
Yes, sir. We
Yes,
are
yes, sir.
initializing new
Yeah, we are
midpoint.
checking. Correct. We are checking that hey, current mid is equivalent to the previous value or not. If it is, change the mid to that. Decrement the mid now. And we keep doing it. When this condition will become false, when the left element of current mid is not equivalent to the same value, which is what in this condition 3, 4, your mid will be at 4 at this one, and the previous element is 3 is not equivalent to 4, so you will just return the mid here. Now the question is why we are doing this. If I don't do this now, then you will keep decrementing and you will end up trying to, let's say mid became 0, you will say array 0 and then array 0 minus 1, which is what, -1. Does that exist? No. So you will get a compiler error there, and we don't even need to check it. If mid becomes 0, that means we have already reached to the end, to the beginning of the array. I mean, there is nothing more to check in the left. We are already at the starting, so that will be the straightforward answer. That's why we were using this mid greater than 0. Otherwise, there can be a possibility where this condition, this line will give us a compilation error. We have done the same thing in the 2-pointer approach also, by the way. Same thing. Is this clear to everyone?
Yes, sir. Clear.
Okay. What about Sadia, Omkar, Aryan? Okay. I have one more question then. Okay. I think I need to do one more thing. Just one second. So regarding your Java code, just to yeah. So I forgot the name. I think it was Style somewhere. So Sahil, this is the Java code. So just go through it, and if you see there is any issue, just let me know right now. We'll wait for 1 minute and then we will move on to the next part. Let me know if any one of you have any doubt related to any code, maybe approach, anything else. This is the Java code in the current screen. Hopefully my screen is shared. Yeah, I think so. Okay, it seems this code is also clear. Let me check the chat again. Got it, sir. Okay. Okay. Now I have another question. Instead of finding the first index, what if I say we need to find out the last index of the target? Instead of first, find out last. Tell
Same.
me how we will solve this. Sorry, someone was saying something. Just go ahead.
Yeah, we'll do the same thing, but instead of going to the right,
That's
yeah,
Okay. Is it clear to everyone? Do we need to write, I mean, do you want me to write the code for this again? I will just change few things only. That's it. Take your 30 seconds and then let me know. No questions. Okay. But if I ask second last index of the target,
then like whatever with the last value will just increment one.
okay. Okay. So everyone have got the binary search concept now, hopefully. There is no problem in anything. We will start doing some lead code questions now.
Sir, explain the second last position for the.
So, sorry, can you come again with the question?
Sir, I was asking for the second last repetition of the
Not the
target
repetition, in
element.
the index of the target. Correct, correct. Yeah, same thing. Yeah,
Second
correct,
last.
same thing. Mhm. What is the question? I mean,
Sir, how we'll find the second last
okay.
the element? Yeah.
Can you find out the last index?
Yes, sir.
So, last minus 1, done.
Okay.
Let's say last is at 5, fifth index. Second last will be what? 5 minus 1, which is 4. There should be just one check here. Check that whether the element is the same equivalent to target or not. Sometimes, let's say, there are only 4 repetition of anything in the question, and they are saying, hey, find out the 10th last index. So maybe that doesn't, but it will not happen most of the time. But just saying that, make sure you are adding that check there. That hey, don't blindly say that last minus 1 would be the answer. Check whether the last minus 1 is also equivalent to the target. If it is equivalent to the target, then you got the answer. Otherwise, return that hey, no answer exists. There is no second last in the given. I mean, some that would be given in the question itself. That what to return in that case. Maybe mostly negative one. Okay. Since anyone have any other question? Okay. Start reading this question. I will give you 2 minutes and try to read this question. Yes.
Sir,
Yep.
sir, that last one, you should minimize the number of calls uh, to the API means.
So you remember we used the linear search and find out the answer in 4 comparisons. The comparison meant the number of calls here. Number of time you are calling that function, you need to minimize that. Okay. So let's say, see, you can find out the answer by calling that function for every version. That would, let's say, take 100 calls. They are saying if there is any way you can find out the same answer with 20 calls, 15 calls, 5 calls, then please return that number of calls which you will require. That means use the resource very less. I mean, don't try to abuse the resource, basically. If you can do something in 4 calls only, just do it. Don't use 10 calls. This is what they're trying to do. So return that minimum number of calls which you will require to find out the answer. Okay, hopefully you guys have read the question. So what are you able to understand from the question? Anyone?
Uh,
I mean, you must have got something.
Yeah,
Go ahead.
we need to find first bad version. So,
What
so,
does that mean?
so we are given with an array which contains multiple revisions of an API. But
Of
there,
us? Okay. Yeah.
but there is one. So the problem is that each time we revise the API, it's uses previous API as a base, right? So one of the API is bad, and all the APIs after that would be bad. So we just need to find the first API which caused the error, like which is bad.
Okay. 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 So for everyone, I would give you example. For let's say you are cheating in your class and you are cheating from a topper, let's say. Okay. A topper has made a mistake in writing the answer, and you all guys are kind of cheating from him or her. So whatever mistake he has done or she has done, definitely you are also going to do the same mistake in your answer sheet. The same thing is happening here. So whenever a software is, so you know this Windows 7, Windows 11, Windows XP, all these are called versions. 7, 11, 8, 9, 10, 11. All these things are called versions, basically. Multiple iterations of the same software. So they are saying that you are given a N version of a product, or you can say a software, which is 1, 2, 3, 4, 5, 6, 7, 8 till n. Now they are saying there was a bug which got introduced in one of the version. Let's say it can be 5, it can be 6, it can be 7. Since that bug was not fixed by the developer, it kept on passing to the newer version. That means if the fifth version is a bad version, then 6, 7, 8, 9, 10, 11, 12 till nth, all of them will be the bad version. The question here is to find out what is that first version which was bad. In our example, it is 5. This is what you need to find. Now, they have given an API called is bad version. API is just a, you can say, inbuilt function, which, for example, you use sort, you use dot size, you use dot length, you use some other function, cout, cin, system.printout. Similarly, there is another API or a function called is bad version, which you can call, pass an integer to it. It will tell you, it will return a boolean value. It's a yes, true, or false. It will tell that, hey, this version is bad. That's the only thing which that function will tell you. But you need to find out what was that first corrupt bad version. Who was the first firstly corrupted? Then definitely all the other version, whatever goes after that, are corrupted, as I mentioned. But you need to find that, hey, first version was fine, 1 was fine, 2 was fine, 3 was fine, 4 was fine, but then 5th was corrupted. And then 6th was corrupted, 7th was corrupted. But what was the first version? It was 5th. The thing which we just discussed, first index of the 4, first, last index, the same thing. Is it clear to everyone now? Hopefully the question is clear.
Yes, sir, clear.
How we are going to solve it?
So firstly, we'll find the mid, and if we got a result if we got the true result, then we'll move forward for the
When you say
next
move forward, you mean left or right?
left to right.
Okay, let's say current mid is true. That means the current mid is a bad version. So will you go to the left part of that mid or right part
Sorry,
of it?
right to left. Sorry, sir, right to left.
Either say
Yeah,
left
we
half or
move
right
left
half.
part. The left part.
Okay. Then what? Then what?
Continue until we are getting true from the API.
Okay. The way we did it with the first index, that can be also, that could have also have done. No? Key that we found at the mid, we got to know this is true. Then use the loop, while loop, keep iterating till the left until we keep getting the same value. This is the same thing also. I will show you one thing. In this array, we have just done this question. If I remove everything and only keep one thing here, I'm creating a new array, which is 1, 1, 1, 2, 2, 2. Don't you think this question and that question is same? You can consider 1, 1, 1 is a good version and 2, 2, 2 is a bad version. So don't you think this is exactly same question? So we could have applied the same solution there.
Yes.
Yes. What about others?
So again,
In previous question, we have already find out the first index of the target. Okay.
yes.
So if you see the array is already on the screen, which is 1, 2, 3, 4, 4, 5, 5, 6, 6, 7. Now I'm saying, let's say there is an array called where the array numbers are 1, 1, 1, 2, 2, and 2. If you consider 1 as a good version and 2 as a bad version, so then don't you think the previous question which we did, which was first index of the target, and the current question which we are doing, the bad version, is exactly same? We even don't need to change anything in the code at all. Frankly, maybe here and there some issues. Okay. What about others? Like, is it clear to everyone what I'm trying to say? seems yes. Okay. Can we solve it in a better way? For example, what if all of them are true? Then don't you think it can take more time? It can take too much time. I mean, there can be a sample where the time complex, where let's not talk about time complexity, where the number of comparisons which we are going to do in binary search can become equal to linear search. Can we somehow improve it? Because if you see the code here, this while loop is itself a linear search. Can we improve this? This is a linear search. We are just moving linearly. When I say linearly, one by one, basically. Can we somehow improve this?
I guess
Can we go ahead.
instead of directly like finding the answer in this iteration only, what we can do, we can set low to mid
what?
so that the while loop keeps continue.
You will go to the okay. Let's say you find out the target. So will you go to the left half or right half?
I'll go to the left half. Like first of all, I'll just
So
store
why we will?
the
So why we
possible
will change
answer.
no? Mhm.
Can you please repeat what?
So you said that you will change the value of no, and then you said that we are going to go in the left half. So why do we need to change the value of low then? I mean, we need to change the value of high in that
Uh,
case.
we need to find the first occurrence, right? Oh,
Correct.
wait a second, just a second. Yeah, we need to set high equals to mid minus one.
Okay, let's say we did it, then what?
Then the loop will continue, right? The binary
So how
search.
we will get the answer? I mean, this way target will be keep. Let's say it will keep becoming equal to mid. I mean, at what point we will get to know this is the answer? That's what I'm trying to. Saying that a loop will finish, that cannot be answer actually. Let's say you say that hey, once the loop finish the answer, we will get the answer. Where is that answer? Where are you holding it? And how you will get to know that?
At high.
Can you elaborate more when you say high? What do you mean by that?
I'm not sure. Like I'm just thinking that once we move high to mid minus.
No, that is straight away. You can say linear search. Sorry. Yeah. Okay. Let's come to the code. Let me tell you how you will do it. There are two ways. One is creating another variable called IANS. I mean, you can name it something else also. It's not necessary. Or you can directly use low and high value. Let's first go with the easier approach, which is very easy to understand. Let's come here. Let's take a simple example. 1, 1, 1, 1, 2, 2. Zero, 1, 2, 3, 4, 5, 6, 7. Low ANS. Initially in the binary search, what will be the value of low and high? Just go fast this time. I want the instant answers. What
0,
will be the value of low? 0. What will be the value of high?
7.
7. What will be our mid?
4.
What will be the mid?
Like depends which value are you taking, seal value or floor value. Like in Python, as per integer division, it will be 3.
Based on the code I have written, just tell me that. Based on the code we have written. I have not used seal, I have not used flow. Based on the code which we have written, which is, if you want to see it again, which is this one, what will be the value of it?
3.
Okay. So the value is 3, which is here. Let's say we are looking to find out the target is 1. First version of 1. Okay. Now what will be your next step?
So लाइक अब मुझे पता है कि मेरा एक बार मुझे 1 मिल चुका है, राइट? तो
Correct.
मैं अब इस एरे को भूल ही जाऊंगा, मैं इससे आगे का पार्ट भूल जाऊंगा, 3 से आगे का मैं देखूंगा कि 0 से लेकर 2 के बीच में भी क्या 1 एग्जिस्ट करता है या नहीं। इसलिए मैं हाई को उठाकर मिड -1 पे रख दूंगा, ताकि मेरी जो बची हुई एरे उसमें भी एक और
So
चांस।
low will be 0 and high will be what? 2.
करेक्ट।
What will be the next mid? I have one more thing, the extra layer which you just said. So you have already find out that here we have already find out the target. What was the index where you saw the target? It was 3. So I will store it here. Whenever you find the target, you will update the ANS. When did you find the target last time? At third index, when the mid was 3. So
राइट।
you will store that value here in the ANS. Correct? Let's go to the next step. You said that new low will be 0, still 0. New high will be 2. What will be the next mid? What will be the mid now?
मिड विल बी 1।
1. 1 means here. Hey, again we got the target 1. So we will again update the ANS. Now the new value of the ANS will be what? 1.
1
What will be the new value of low and high?
0 0
0. 0. What will be the new mid?
0।
We again found out the target. So we will update the value of ANS. Now the loop will end. Whatever is the value of ANS currently, you return it. What is that now?
0
0. Let's say our target is 2 now. Let's change it. Let me erase the things and let's try to run it again. What will be low and high? Then what is mid? 3. What is at third? 3 position. It is 1. What should we do now?
The low is equal to mid plus 1.
Tell me the value. Correct. Now what will be the next mid? 5. What is the value at 5? Hey, we found the target. The target is here 2. And what is the current mid? It is 5. So update the ANS with 5. Now, what will be the new low and high? We are at here. What is the new value of low and high?
The new low are 6 and high 7.
Sorry?
6 and 7 sir.
4
Your voice is not clear to me. Okay, 4. Low will be 4 and what will be the high?
4
Okay. What will be the mid?
4
4. Hey, we found the target again. 1, 2, 1, 3. When I'm using 3 dash, that means it's the third traversal. When I'm using single dash, it's first traversal. When I'm using double, that means it was second traversal. So you can consider it as a denotation. We found the target again. What is the current mid, which we got the answer, which is 4. Update the ANS with 4. Now there is nothing to end. I mean, we are done. What is the answer? That's it. This is the way you can do the things. Clear to everyone?
Yes, but you mentioned like we can also solve this without a variable. Like you said,
I mean, yeah, we don't need extra variable, which is the CMS. You can just return the low and high.
so like I'll found the value at low or high, like or always like both will be same always.
Can you come again?
Like this is the question you asked, now. Like at what pointer I'll found the value. Will
It
it be
depends how you write the code. it depends on how you write the code, whether to return the low or high. But one of them will have the answer. Okay. Again, I'm not sure. Should I explain this process? It will be a little bit complicated. But if you remember, whenever we write the condition, we sometimes write this low. When you will solve the question on LeetCode, now somewhere you will see this, and somewhere you will see this. Okay, nothing is wrong. Both are according to the questions. I would suggest you start doing some questions. Based on your implementation, it tells whether to return low or high. I will not make it more complicated because this is not a very big thing, at least for now. Without this, you can simply use extra variable and you will be able to find out the answer in every question whenever you use the binary search. We will discuss it later on. I would suggest you to note it down somewhere in one upcoming sessions when you guys have done some questions, you have seen some code, then we will discuss this part that hey, what to return low or high and when to return high. So we can discuss it later on, but note it down at you. We can do it later. But for now, I think this is the simplest thing to do, and there will be no confusion when you are going to do this. Actually, there you will see multiple confusion. That's why I'm avoiding it for now. But later on, we will do it like the way we did that building problem.
Okay.
Any other questions from others? Should I take it as no? Okay, seems yes. So do you guys think I should write the code for this or is it good enough? It seems we don't need to write the code. Okay, then we can move on to the next question. Just give me a second. Let me get the next question. Read this question. Hopefully my screen is there. Yeah.
Yes.
Uh, done.
Yes.
What about others? By the way, non-decreasing means increasing. Okay, just to clarify for everyone. And non-increasing means decreasing. That's it. Okay, so this question is clear to everyone. Omkar, Sadia, Bipin, Aryan, Sahil, and others. If no, say no. Otherwise, I will consider it yes.
Sir, it was little bit confusing to understand. Can you please explain the question?
Okay. We are given an array which is in the decreasing order. So you know the alphabet. So when we say A, B, C, D, it's always an increasing format, and they have given it here in the descending order, basically Z, Y, and something like that way, reversely. You are given a target. What comes after A? Tell me that.
B.
Does B is B in the given array of the example one?
No,
What comes after that? I mean, after A comes B, but since B is not here, what is next?
it would be C, sir.
C exists in this given array.
Yes, sir.
That means we got the answer. The question is saying that you are given an array, you are given a target, you need to find the character which is greater than target and most closest to the target. See, if you talk about greater than target, let's say A, B is also greater than A, C is also greater than A, D is also greater than. Does that mean B, C, D, E, F, G, H, everything is the answer? No. They are saying it should be greater than target, but the smallest character, smallest in between them. What is greater than A? B, C, D, E, F, G, H. What is the smallest here? It is B. But B is B available in the given array? No. What is the next smallest? It is C. So C would be the answer. Straightforward. What is the smallest character which is greater than A, which exists in the given letter set? This is the question. So instead of finding out A, you need to find out that hey, whatever comes after A, check whether what is that value which is in the given letters actually. Let's start with a basic concept. How you will solve this question with a very basic approach. This is very strict. If you solve this question by using forcefully applying the concept, you will fail. Try to normally think how you will solve this problem. Start with a very brute force approach. I would say, hey, start iterating over the arrays, over the given letters array. Check, is C greater than A? Yes, hey, I got the answer. Done. Done. Next example. Is this C greater than this C? No. Is this F greater than this C? A? Yes. We got the answer because the array is already sorted. So we don't need to give a shit about whatever is after it because it's always going to be greater than that. Greater than that. Again, next. Is X greater than Z? No. Now you will say, hey, how the answer is X now? Read the explanation. There are no characters in the letters. After that, nothing comes up. So logically, there cannot be any answer here at all. That's why they have returned this letter 0. That's it. It's just a exception case. They must have also mentioned it here. Yeah. If such a character does not exist, after that nothing comes up. That means that satisfies this condition. If such a character does not exist, return the first letter in the letter. That's why the answer is X. That's it. Is this question clear to everyone now? Hopefully, I am audible to everyone. Okay. Is this question clear to everyone now?
Yes, sir, clear.
But
Your voice is breaking.
Sir, your voice is breaking.
Is it fine now?
Yes.
Yeah.
Okay. What I was saying that if the question is clear to everyone and the first solution, the brute force solution, the linear search solution which I have given is clear to everyone, let's move on to the next solution. What will be the more optimized solution for this? Can anyone tell me that?
Yeah, we can use the same approach which we used in the last question. Like we can store the potential answer, and then again we'll just divide the array and iterate over the half part.
Okay. Does this make sense for others also? And what code changes you will make here? Tell me that.
So like first of all, now it's not equals to. We need to find the first greater element, right? So my potential answer will lie in this portion. So if my
So
array of,
what should I write?
if my array of mid is uh, we need to find first greater, right?
Sorry,
Yeah.
we need to find
First,
correct.
so array of mid is
Correct.
greater than the target, then that means that it's a possible answer, right? It's a potential answer. So we'll just use greater than here and store potential answer, the value of mid in.
Okay, done.
Then I'll just move my high to mid -1 and will give the rest of the array a
I mean, rest of the things would stay same.
your voice is
Or
breaking.
do you think anything would? I was saying that rest of the things should stay same, or do you think something will change?
Yeah, same.
Okay. What about others? Is this clear to everyone? Say it loud. I mean,
Sir,
if it
please
is clear.
repeat this part.
Okay. So the solution which he mentioned was that hey, we are going to use the binary search. What we are doing here, whenever we find out the mid, we check whether the current mid value is greater than target or not. If it is greater than target, then we set the answer to this mid. If you remember, we just before this we did that now uh, uh, first index of target. So this is something related to that. If you come
Your voice is breaking.
which is F great. Just give me a second. Maybe some internet connection issue. Is it fine now?
Yes.
Okay. Yeah. I was saying this is the given array. Okay. First it's the 0 index, then it's a 1 index, then it's a 2 index. What will be the mid of this array? It is going to be the first index, which is F. Is F greater than A? Yes, it is. So we can say that, hey, the answer can be F. Now, what we are trying to say is, hey, is there any other value which is lesser than F and greater than A? To find that, we will go to the left half and then we will check C. Hey, is C greater than A? Yes, it is. So we will store this C to the answer and we will return that. The same thing which we have done here, if you remember.
Yes.
The only difference is we, instead of checking that, hey, the target is equivalent to the grid value, we check if it is greater than that or not. That's it. Nothing else is changing. Clear to everyone?
Yes, sir.
Okay, then let's. If it is yes from everyone, then I will move on to the next.
One question. So like when we are setting the potential answer, we don't need to move high.
Can you come again with I'm not clear what you're trying to ask.
Like when we are storing that potential answer, that answer is equal to mid, we don't need to change high equals to mid.
Everything else will go on. Answer equivalent to mid is an additional layer. That's it. I would say it that way. The basics of binary search will not change. Either you will change the value of low or you will change the value of high. Otherwise, this will enter into the infinite loop. So even when you are doing ANS equivalent to mid, if we come back to the code again, yeah, here also we are going to update the value for sure.
Yeah.
We are going to do this. Okay.
Yeah.
Sorry, mid minus. Sorry, mid minus, not high minus. Okay. Any other question?
Sir, what was the question number for the both the LinkedIn problem?
What is the question number?
Yeah, for the current question, what is the LinkedIn question number?
Not able to clearly hear you. Sorry. Can you write your question in the chat maybe because your voice is not clear to me. Or if anyone else have got it, then maybe they can reiterate for me and then I can say it better. I'm waiting for your question in the chat. Question? Number of question in the LeetCode. This is more confusing for me now. Have anyone got it like what he is trying to ask?
He is asking, I think, LeetCode question number, like the question.
Got it. Okay. Question number. Okay. Got it. Yeah. Sending you the link straightforward. Yep. Got it. Sorry. I've sent you the question link itself. So you don't need even the question.
And one more small
Okay.
thing, in code, we set, I guess, I think we set low, right? But we need to set high because we need to find first greater, right?
Okay. Yeah, correct. If it is, if you want to go left, set high. If you want to go right, it set. So actually, the code was written for high. I think. That's all. Yeah, but for you're right. If you are looking for the first value, then you will always set high. Not always. You will set high when you get the target eventually. And if you are finding the last value of something, then you will eventually choose the low value.
Okay.
Any other question from anyone else?
Like one simple answer would be for this question, like it is not guaranteed that target will be given. Like if it is guaranteed that target will be given, then we
Yeah,
can.
you will check first and last value, and then that can be also one of the things. If
Yeah.
you will check first and last whether that is there. Yeah, so Omkar, Sadia, Aryan, Sahil, have you got the question? Aryan said got it, okay. What about others? Yes, sir. Omkar and Sadia and Bipin.
Yes, sir.
Okay, and how we are going to solve it now? Since you have got it, so let's see how you are going to solve this.
और इस पे शायद हम लीनियर सर्च अप्लाई कर सकते हैं और जिस इंडेक्स पे वो वैल्यू मिलेगी उस इंडेक्स पे एक माइनस करके उसका रोटेशन का टाइम मतलब कितना टाइम रोटेट हुआ ये बता सकते हैं
Then
देन वो आउटपुट जो है वो रिटर्न कर देगा मिनिमल जो लिस्ट काउंट होगा उस एलिमेंट में
how the let's say you find it out that how many time they have rotated the array. Let's say it's k times. Then what you're going to do? I mean, what would be your next step?
Right.
Anyone?
We need to solve it in log n. Otherwise, we can just simply linearly traverse and check if left value and right value both are greater than my current, then like my current has to be the minimum. It's compulsory sort of thing.
Okay. Let's see what we have. Let's say I am rotating it.
We are only seeing your LeetCode screen.
Now,
Yeah, now it's easy.
okay. So let's say this was the initial array. This is the final array. After rotation, how it will be? Are they doing left rotation or are they doing right rotation? Okay, 3, 4, 5, 1. This is the given array. So someone said if we find out how many times they did the rotation. Okay, my question is how you will find it out. Okay, this is also one of the learning here. Find how many times array is rotated. How you will find it out? Let's first do this question. This is where the simplest question. This is the simplest thing to do. There is one more thing which you may have missed out. The numbers are always between uh,
Okay, 1 to n.
1 to n, correct. And n is the length here.
Then whatever be the first element, that might be the number of rotation.
Are you saying 3 is the number of rotation in that sense?
3 minus 1. Yeah.
Okay. Is it clear for everyone? Should I take it as yes? Okay. Let's say we got the answer right. It is rotated 2 times. Is it helpful for us in any way to find out the answer? By the way, what we need to find out, I should check that also. Okay, find the minimum element of the array. Okay. First clarification is that numbers are not from 1 to n, actually. The formula which we have just used, or the which Sandeep mentioned, can only apply when it is given that the numbers is from 1 to length n. From 1 to n, and n is equivalent to length. Okay, now you know what is k, and we have these conditions on. How you will find out the minimum element here?
I guess Adin is asking to explain it once.
Okay. When you know that the numbers are from 1 to n and the length is also n, so that means they are actually representing their indexes. I'll tell you how. Numbers are from 1 to n, and n is, let's say, 5 here. 1, 2, 3, 4, 5. What will be their indexes? 0, 1, 2, 3, 4. Let's say we are rotating this array. How we will rotate it? Let's first see that. The rotation is done in this way. 2, 3, 4, 5, 1. Another rotation. 3, 4, 5, 1, 2. Every rotation is displacing the element correct index by 1. 1 was at correct place initially, 2 was correct place, 3 was at correct place, 4 was at correct place, 5, because everything was ordered. Once we did one rotation, their position got changed by 1 index. 2 should be here, but 2 have gone there. 3 should be here, but it has gone there. Once we did another rotation, then every element was affected by 2 times. If you know that the elements are from 1 to n and the size of the array is 1 to n, what should be the first value here in the sorted? It should be 1, na? But it is coming 3 here. That means in 1 to 3, how many elements are there? 2, and then 1 is 1 again itself. That means before 3, 1 and 2 was there and they got removed because of rotation. So how many rotation they must have done? 2. 1 and 2. Sorted array have to had 1 and 2 before 3. But the final array didn't have 1 and 2. So how many rotations they did? Simple thing, 2. If this is a condition, this is not given in the question. The question is something different from this one. If the size of the given array is n and all the elements are from 1 to n, these things applied only there. Is it clear now? Aryan.
Yes, sir.
Okay, great. Let's come back to our video. I forgot what I was asking. So, yeah, my question was: let's say you find out the k, which is number of times you array rotated. Now, how can you use this information to find out the answer? Although you already know the answer actually. Why? I mean, we know the one is the answer. Frankly, the question was to find out the minimum element in the given array. If we know element always have 1 to n and then everything is this and that, we already know the answer that hey, 1 is the smallest one. But can we use somehow to find? Can we somehow use this k, which we have found out, to find the answer? Yes or no? And if yes, then how?
Like if k is greater than 0, then traverse k times from the last. That would be the answer.
Why do we even need to traverse? Simply get the kth element from the last. That's the answer. Simple.
Yeah, it's a array, right?
Get the kth element from the last, and we got that. Is this clear to everyone? Then we will jump to the question which we actually had actually. We just move on the question. Seems yes. Then let's move on. Now let's come to the real question. They have nowhere mentioned that the value will be always 1 to n. The value can be anything. First thing is that. And we will take the example that case also. Let's say the given initial array was 1, 0, 2, 3, 4, 5, and 8. They did rotations and the array became something like, what should be the rotated array? Tell me that.
3, 4, 5, 8, 0, 2.
Okay. This is our final array which we need to use to find the answer. How can we find the answer in this question? Think about it. One simplest way would be to linear search. and we have got the answer. Is there any other way? Can't we use binary search here, by the way?
So it is not sorted.
Okay, it is sorted, but the sorted, actually it is sorted in two halves. I will show you it. The array is sorted, but in two parts. I mean, one half is sorted in some way, and other half is sorted in some way. I will show you what I'm trying to say. If you, sorry, I need to make a straight cut. Also, let's erase this since we don't rush it to this one. Don't you think the left and right part of the both is sorted?
Yes.
Let's try to apply binary search. Let's see what. Okay. Low, high, mid. What we need to find out the smallest element. Let's say ANS search. Although I don't think so, it will not be required, but let's see later. What will be the value of low?
0,
High,
5,
mid,
2,
now. What is the value at mid 2?
5,
What is the value at left?
4,
3. The low, sorry. What is the value at low?
3, 3,
What is the value at high?
2.
Compare this and this. Are you getting any information by comparing 3 with 5?
Yeah, like now I can surely say that uh 2 is minimum than like
No,
the
what I was trying to say with this information now, this makes sure that whatever element is between 3 and 5, they are sorted. What I mean by that is that from 0 to 5, sorry, from 0 to 2, every element is sorted. So we can consider binary search applying there directly. What was the motive of the question? I mean, your question was, hey, array is not sorted. But now we got to know that, hey, from 0 to 2, array is already sorted, completely sorted. Okay. That means if we want to find out that means, sorry. Okay, let's first go
it
back to the same thing.
will it be always the case that first half will always be sorted?
If this condition fails to be true, it's not about first half, it's about low to high. Sorry, low to mid.
Okay.
Are we getting anything from this condition?
Somewhere minimum lies in this part.
It can lie. Okay. If you compare 5 and 2, you got to know that, hey, there are some elements which are smaller than 5 and which are in the right order. Hey, but now we are confused. Should we go to left or should we go to right? The decision can be made by comparing low and high directly. If you compare low and high, what are you getting from that?
That the right part
Will
is
have the smaller element than the right than the left part.
right.
So let's do it. What will be our new low?
3 plus 1. Okay, mid was 2 or 3.
What will be one new mid?
4.
Let's do the same thing again. What is at 4?
0.
What is at low?
8.
What is at high?
2.
What are you getting from these comparisons? It says if we compare 8 and 0, we got to know what we are getting from it. Think. Now you only need to think about 802 because other thing we have cut it. Don't think about 345 at all. This is the only thing which is left on the table. And also one more thing, whatever comparisons we are doing, they are based on how the array is rotated. For this one, the array was rotated from left to right. If the array would have rotated different way, the comparisons or the way you would find out whether to go left and right would also change. What are you getting from these three comparisons, which we are going to do between 8, 0, and 2? Let's start with the easy comparison, 0 to 2. You got to know that, hey, from 0 to 2, every element is sorted. So if you go after 0, there is no point to go there. Correct? There is no point to go into the right because from 0 to 2, every element is sorted. And if you are going to go right, you are not going to get a minimum element. The current minimum is 0. If let's talk about left, but hey, we can go to left. There can be a possibility. Is there any possibility that we should go to the left? Right, we don't need to go for sure. That is done. Yes, there can be. There can be. Are you clear? Are you guys getting it? Say yes, no. Like science is like not good.
Yeah, right part we got it. Like all the elements will be greater than the 0, but left
Then
part.
go to left part. Simple thing. Go to left part.
Yeah, that's
You have a strong assurance that you don't need to go right part. Yes or no? That's very strong. I mean,
correct.
so just go to left. That's it. The way you are going to write the code, you will see all these conditions by the way there. Okay, but nothing is there between 8 and 0, frankly. So uh, it's not going to happen anything. But let's say if I add some extra addition there and try to do something, then you would have been in a position something like this. Maybe.
This one maybe in between.
Yeah, there maybe 1 was here and 0 was here. And then you would have got it with this way. In right, we have assurance that every element is sorted. So if we go right, definitely we are going to get a bigger element. But in the left, we are confused. We don't know what is going to be there.
Yeah, okay. There can be 9 as well. There can be -1 as well. Okay.
There can be 9 as well. There can be smaller element also,
Right.
as you mentioned. So we will go to right and we will see. This is one of the way to find out the solution. Okay, I know this is very complex, but this is not a complex thing. You will see much more complex things. Other way can be you find out that point from where both the arrays are sorted. For example, I told you this partition. These partitions tell you that you should consider this entire array, this and this, and you apply two binaries such straightforward from 3 to 8 and then 0 to separately, and you can get the answer. It will require two binary search. But how you will find out the partition? That will be the question again.
Sir, I'm not getting it. It's very complicated.
Yeah, I know that's why I've done it in the last. So we are already at end of the session. So I will suggest you to spend some time on this question, read more from the discussion. In the next session, we are going to start from this only. And yeah, don't worry. I'm also sharing the question link, so you guys can go there and check it out. So this is the thing.
Where in the next session we'll discuss this question, no?
Yeah, we will start this question. I would suggest you guys to at least spend some time on the discussions. Try to understand whatever we have discussed today, and read the other people's what they are trying to say in the lead code discussions, lead code solutions, editorial if it is open for discussion. So try to do some research at your end, and then definitely we will start from this question for sure. Okay, it seems no one have any other questions. So okay, yeah, we can call it off for today. I will share a list of the questions for binary search, and guys, please solve the question. That is the most important thing. So you should spend time on writing the more and more code, doing more and more questions. That is going to be better for you only. I don't have anything else to say. So yeah. Any feedback from your side? Anything we should try to uh, maybe improve or whatever?
Sir, uh, I am facing problem in writing the code like logic. I'm clear with the logic, but while writing the code, I'm facing problem.
Like what problem? You are not able to write the code? I mean, like what?
I'm not able to write the code on my own. Like I need help in that.
Okay, and how many questions you have solved till now?
Sir, like not on my own. I've just seen the solution.
Yeah, so that is the issue. Initially, you will need some help in watching someone's code and then doing it, kind of a co-pilot, I would say. But at least first try to solve 10 on 15 questions, okay? And then let's see what you are facing the issue. If you have not completed any questions till now by yourself, start with a basic question, maybe two some, openly lead code questions, a very basic thing, maybe just addition or something else. Start with that. Also, you guys already have a group, but whatever problems you are getting, just dump it there. Try to answer each other's question. That would be better. And whenever we are going to have the doubt sessions, I will definitely take your code issue. Or maybe in the, yeah, let's do one thing. Tomorrow, I will try to, let's say, have 5 minutes or 10 minutes just to see what issue you are getting while you are trying to write the code. So make sure when you join the class tomorrow, you inform me or you remember me about this. Maybe Subhahu, I think you said that you will help me out with check it out, like the issue which I am facing with the code. Just mention it tomorrow, and then yeah, we will spend maybe 5 to 10 minutes initially, and then we will move on with the other session. Okay.
Okay, sir.
Yeah. Anyone else? No? Any feedback anyone want to give? Any change you think we should do? Anything better thing I can do from my side? Anything which can help you, which I can help you out in any way? I mean, just say it out. Okay. I think we can wrap it up for today. Make sure, guys, you spend some time on the last question which you have discussed. And if you are not doing questions after the sessions or in the throughout the weekdays, nothing, it will not work out for you. So make sure you are doing that thing. And if you have any doubt, you can consider first 5 to 10 minutes for every session for those small doubts. I can take that those things in every session. That is fine. But you need to do questions from your own side. You need to start doing that. Okay, I think we are done for today. You guys can feel free to drop off. We will meet tomorrow. We will continue with the same questions. Yep.